All right. So anyway, I'm Dan. So y'all have seen me sitting here for a while. Today you get to enjoy the Dan session. So anyway, we're going to get started off here. It says practical circuits there, but I think what went in the email was station setup.
Yeah, I don't know
why
why.
operating. Yeah. So anyway, we're going to go ahead and get started with that. Maybe. All right. So in the earlier days, so like, and the only reason you really need to know this is because if you go out looking for a vintage system, you're going to be looking for two units. You're going to be looking for a transmitter and a receiver. So they were separate units back in the day, back in the old days. And nowadays it's much easier because everything's combined into one unit. So you don't have to worry about interconnecting wires or having your receiver still open when you're pressing on the push to talk button and fry your receiver. You don't have to worry about
the same antenna.
Yeah.
You
Yeah,
have two coaxes coming in?
No, not with a transceiver.
But
If you
Well,
do
I'm
with
talking
a-
about in the old days, you have to have one for receiving and one for
And some sort of switch.
switch. Yeah, okay.
okay, so anyway, and then there's also a transverter. And transverter, I've never used transverter, but what it does is it'll convert your HF signals for your transmit and receive into another band, which would typically be VHF, UHF, or other bands.
It's usually in the doing UHF, VHF on an HF receiver.
So, and everybody should remember that, can I minimize this?
Mhm.
Can I minimize that?
Yeah.
Okay. So everybody should remember that anything you see on red in here is probably tied to a question on the test in some way.
I've seen that
in the
question.
Test bank. Okay, so anyway, moving on to the next one. What is a transceiver?
Alpha.
Alpha, a device that combines the receiver and the transmitter. Sounds like a good one. And then we have a device that converts RF inputs and outputs of a transceiver to another band.
Alpha?
No,
No, be Charlie, wouldn't it? Transfer.
transverter. Remember that it converts from one band to another. So a transverter converts.
I don't know why they didn't just call it a converter.
They had to make it complicated.
I'm the government again.
Yes. Okay, so typical transceivers have the following power outputs. Okay, your handheld, like my handheld right here is 5 watts, and I don't know that I would want to put an antenna for 5 watts up next to my face. Now it's only there for a few seconds, and then I pull it away to listen.
Yeah, this is 8 watts here.
And that one's 8 watts. And you said you actually tested yours, and it got what out of it?
I got 8 point something. I can't remember.
Okay, and
I
you
mean,
remember?
7 point something.
Okay, and do you remember what band that was on?
It was on the GMRS.
Okay, so that's up in the 400s. Okay.
Yeah.
All right. So anyway, typically the handhelds are 5 watts. There are some that are 8 and even 10 watts. I don't think I've seen anything higher than that. Your typical mobile station, mine is not a typical mobile station because mine's only 25 watts, but your typical UHF, VHF mobile station is 50 watts for most of them.
That's what mine is. Yeah.
And then your base, the number that they seem to have settled on is 100 watts. There are very rare instances you'll find HF transceiver that has a 200 watt output. Now, whether or not it's a true 200 watts, I don't know. I don't know anybody
For
that has them.
$13,000,
It should be. Yeah, you should get every one of those 200 watts. But yeah, power is money. That's what you have to remember with your radio. The more power you get, the more it's going to cost you. Then we also have an RF power amplifier. So if you go with the 100-watt transceiver because it's less expensive by a long shot than the 200-watt transceiver, you can get an RF power amplifier at a later time when you've got more money to spend. And the RF power amplifier is used to increase your power, and it says up to the legal limits. So
So we are
what you can-
limited to
1500.
1,500 there.
right,
And then on the higher frequencies, it's 200, right? HF, I think,
I'd have to look it
I
up.
think HF is 200. If I remember right.
Yeah,
For a certain band
yeah.
and
Well, on your band chart, that band chart that I've got green and I've got red. So what is the red? I mean, it doesn't give you a reference to go by.
well, you go by the letters out to the right,
Yeah,
whether
it's
it's
like
like technician or
this will say, and various, if not otherwise stated on this card, your limit is around 1,500.
Well, this is a
But-
bit different than the one that I was.
Yeah, some bands are.
Can I have this?
You have more, Bob?
I should have.
Yeah, you can have it.
I didn't give you one.
Okay, so anyway, and then the RF power amplifier, the thing you have to remember about the RF power amplifier is that it functions, it has to set itself up for whichever mode you're using. And some of them, they have to be set to the proper frequency as well. So whichever band you're using, you would have a band switch to select the band that you're going to be using, and then you have to have a switch that selects whether you're using CW or single side band or any other mode that might be on there. And those things are important for being able to get what you need out of it. So what device increases your transmitted power output from a transmitter?
Bravo.
Bravo, an RF power amplifier.
Bravo.
There we
Quick
go.
question for you guys. So the power amplifier is going to be a separate device from the transceiver, right?
Yes, it's a separate box of its own, and
Yeah.
usually, and it does Bob's got a RF amp, I don't. Do they have their own SWR meter?
I'm not familiar with that.
Watt meter
Okay,
may show reflected.
Yeah.
And
Yeah.
forward.
okay. Did you get that, Robert?
Yeah, yes, I do. So the wattage has to match the transceiver, correct?
What's that?
The wattage has to match the transceiver from the power
Uh,
amp.
No,
No, you're probably, when you use a power amp, you're probably going to be transmitting from your transceiver at a lower power.
Okay,
And then the power amp does the bulk of the work, increasing the power up to the level that you want. But you do have, because you're going to be transmitting higher powers, it's absolutely imperative that you remember to set the SWR. And if you have to use an antenna tuner, the antenna tuner can't be between the transceiver and the power amp. It has to be between the power amp and the antenna.
okay.
Okay.
And
So
sorry,
to have-
one more question. What does WSR mean?
SWR is standing wave ratio, and
Okay.
the technical term is VSWR, voltage standing wave ratio, but it's just been shortened to SWR because it's, one letter less to have to remember.
Okay, thank you.
But yeah, that's a pretty important thing. The higher the power goes, the more important your SWR match is going to become, because reflected power will burn out your finals and your amplifier.
I don't want that.
Yes, nobody wants that, especially with power amps, because power amps get rather pricey.
Thank you, sir.
Well, I'll just go ahead and give him that one, and then when you get your cards back, I'll grab another one. What is the function of and remember, we talked about the mode switch. That's what this is all about. What is the function of the single sideband CWFM switch on a VHF power amplifier? And well, you have to be careful with this question. Okay. Some of the questions that you will see on the test, not a lot of them, but some of them, there'll be two right answers, but one of them is just a little more right than the other.
Well, that's what I was talking.
So
about
that-
on my-
Yeah.
That practice test.
Yeah. So I did it last night when I was going over this material. I immediately jumped on A, and there's a more right answer.
Well, actually, A is wrong.
Change the
It
mode
doesn't
of the.
change
Yeah.
the mode of the transmitted signal.
Well, yeah,
It
actually,
changes the
that's right.
mode of the power amplifier.
Changes the mode that the power amplifier is gonna function on, right? Okay, so anybody got a second guess?
I'm going with Charlie.
Okay, I heard a Bravo.
It's either Bravo or Charlie. I think yeah.
Oh, bravo,
Okay.
bravo.
So, yeah, remember we mentioned earlier that the amplifier has to set itself up. Okay, everything has to be connected properly inside the amplifier based on the mode that you're going to be operating. So, and in this case, they said specifically for a VHF power amplifier. Two of the most important transceiver specifications are sensitivity, which is the ability to detect a signal. Okay, so the ability to look at this incoming radio wave and be able to tell that there's an intelligible signal there.
So that's
So
one of the ones I missed. I got,
Got it mixed up.
yeah.
yeah, the sensitivity is how well it picks a signal out of the noise. And in your selectivity, well, let's go ahead and go through the rest of it. The minimum power level at which the receiver can clearly receive a signal. An RF preamplifier can be used to improve sensitivity. So if your radio is not sensitive enough for you, you can get a preamp, which will go between the antenna and the receiver or transceiver, and it will boost the weak signal coming in enough that your radio can pick it up.
A lot of transceivers will have a built-in preamplifiers and attenuator. As we'll talk about later, a strong signal.
Yeah,
I need to,
Turn it down.
7300 has that.
Yeah, the 7300 has it, 7000 has it, and the Xiegu has it, but the one on the Xiegu, it amplifies everything, even the noise. So anyway, and you just remember that, you want that between the antenna and the transceiver. Okay, unless it's built in and then it's already put in the right place, you just have to turn it on. Selectivity is the ability to discriminate between two or more signals that are very close together on the spectrum. Being able to pick which one you want to listen to. Remember that when we talked about VHF, the strongest signal always has the priority. With single sideband on HF, it's not that way.
Hear it all.
You can hear them both, but you might have, and a lot of equipment will have some little filters on it that you can set that helps out with that. But the selectivity of the transceiver to be able to select which close frequency you want to listen to. So anyway, remember sensitivity and selectivity. Sensitivity is the lower ability to detect a signal and pull it out of whatever else is all around it. That's your sensitivity. And selectivity, discriminate between two very close signals.
Actually, in order to detect a signal, you really have to amplify it from possibly microvolts up into the volts range for the demodulator to work. So that's what the amplification of sensitivity means, is in order to get the signal strong enough to demodulate, what's the minimum amount of voltage in microvolts or millivolts? Usually it's microvolts.
Okay, so which term describes the ability of a receiver to detect the presence of a signal?
Bravo.
Bravo, sensitivity. You agree?
I would agree.
Which term describes the ability of a receiver to discriminate between multiple signals? Charlie, selectivity. Very good.
Selectivity.
You'll get that one
Okay.
right from now on, yeah.
They're
That's
so similar, yeah. Sensitive,
Yeah.
selectivity.
Where should an RF preamplifier be installed? This is, of course, an external preamplifier, one that's not already in your unit. Where should it be installed? Alpha. You agree, Robert?
At the output transmitter. Okay, I see where that's coming from, the output. Okay, okay, I agree.
Okay. So between the antenna and the receiver.
Receiver, yep.
Okay, AM receivers, tuned RF. Now this is
historic.
yeah. Yeah, so this is like a very simple design. However, because of all the linkages between tuning, it's also a pain in the neck to keep it tuned. I worked on a radio like this when I was in the Navy. Pretty close to it. Every arrested landing on an aircraft carrier had to recalibrate the radio because it would knock something out every time. So anyway, one of the simplest designs, RF signal is amplified until it's large enough for the demodulator to work. And the demodulator is the green box right there that you can see with the diode on it. The triangle boxes that you see along there are different amplifier stages. And the ones with the boxes, I'm sorry. Let me get back there. The boxes with the, I keep forgetting that Bob's laptop has a touch screen on it. So when I touch the screen, it advances.
And I hate that.
Mine isn't that fancy. But anyway, the square boxes with the squiggly lines in them, those are tuning stages. And all those stages have to be tuned together. And that's one of the problems that you ran into with the ARC 51 radio.
But it's those three stages they show there is what gives us its sensitivity, how much amplification you're getting through that front end.
Yep. Okay, and then came upon now, and even this right here is what was the standard when I started working in electronics way back in the early 80s, without giving up too much on my age. But the super heterodyne receiver was probably, and probably still is, the most popular. A lot of the amateur radios nowadays are going to an SDR type configuration. So, but anyway, most popular, the RF signal converted to one or more intermediate frequencies. And intermediate frequencies, when you look down at the bottom where you see it says IF amplifier and filter right there, the IF means intermediate frequency. They have narrower bandwidth and high selectivity. So they're very good for pulling that signal out of or that one frequency out of a bunch of neighboring frequencies. Part of it there, you can't see at the bottom, is a local, the orange, or I'm sorry, the pink box at the bottom that's hidden behind the bar, that's a local oscillator. So that oscillator input goes to the RF filter and to the mixer, and it's used to mix down to audio frequencies so that you can get.
You can drag that bar up to the top, get it out of the way.
Yeah.
If you can grab it. Or you're gonna do it the hard way.
I was trying to find my pointer. But anyway, any questions on that? Okay. So this is kind of the norm right now for most well, probably all of the modern equipment. It has some level of SDR, and SDR stands for software defined radio. I can't remember what this is direct conversion. What is the other one?
It's basically a hybrid
Okay,
where you may have a local oscillator mixer in the front. And then you digitize the IF. In the case of direct conversion, you're taking the RF signal and sampling it with an analog to digital converter. So you're converting it to digital samples. And then it's processed in the digital world basically by a little computer that's built into the radio. It's usually a FPGA or something like that. But you can do all kinds of filtering and stuff in the digital world that you can't do in the analog world.
Well, I ain't been able to pick up no digital with mine.
Well, you don't see it. To the
Yeah.
outside world, it looks just like a regular
yeah,
older radio, except better.
yeah. The digital part on this, as far as this is concerned, right here, is all in the signal processing. It's not what's transmitted out or received.
You have analog RF coming in, and you have analog audio coming out. And everything in the middle is digital. And the same thing for transmitting. You've got analog voice in, you go digital, and you got analog RF out.
I can pick up the air. I can pick up the tower with mine. AM. I
Which
listen to them bringing in airplanes.
at Merritt Island,
No, Melbourne, I'm in Melbourne.
Melbourne. Okay,
I'm about,
I worked for a company at the Melbourne airport.
yeah, I'm about 6 or 7 miles from the airport.
Okay. Okay, so you'll notice right here, you'll notice you've got a ADC and a DAC. So they're different directions. One of them is converting analog to digital, the other one's converting digital to analog. And the digital to analog is processing it to go out to the antenna. That's on the bottom one right there. The top one, the ADC, analog to digital, is taking your received signal and converting it from analog to a digital signal for processing throughout the rest of it. So, and what is the bottom drawing there, Bob? Is that just a more simplified?
Yeah,
Yeah,
just a bigger block diagrams.
yeah. So the top diagram there is just a little bit more detailed, and this one here just simplifies it a little bit. You see, you still got analog to digital and digital to analog there. So I don't remember if there's SDR questions on this test.
Not seeing any.
I don't think so.
Yeah, okay. But there'll be more on that later. When you decide to
But there
take
will
your
be a question, there
general.
may be a question about mixtures.
Morning, Byron.
Hey,
Okay,
super heterodyne.
super heterodyne receivers use a mixer circuit to convert a radio frequency signal to an intermediate frequency signal. One of the things they taught us in the Navy when I was going through school is that you on the output of it, and I tend to believe that this is only the basics, because I've seen evidence that there's more there than what I saw. But what they do is you put two frequencies in, and on the output you have the sum, the difference, and the two original frequencies available. And then through filters, you pick off which one you want.
And actually, they don't talk about it. You get some harmonics of those two.
Yeah. And the harmonics mix and the
But that just
harmonics mix.
complicates.
Yeah. So anyway, but that's what your frequency does. So you've got your input signal, which would be the signal that comes in on your antenna, and you mix it with a local oscillator frequency. And on the output, remember we were talking a slide or two ago about intermediate frequencies. The signal that you would pick off on the output of your local oscillator, or of the mixer rather, would be your intermediate frequency. Or it may be the first stage of an intermediate frequency and then get mixed again and lowered once more.
So it's going to be either the sum or the difference you have to pick because they're both there.
Yeah.
Whether you want to be a higher frequency or a lower frequency intermediate.
And in the case of receiving, you're trying to break it down to audio, so you're gonna be picking the difference.
Okay, you gonna have a switch on your radio to pick the difference in that?
No, that all happens
For
automatically.
the design.
It's in the design, yeah. Yeah, so,
So how do you pick it?
well,
You
when you
don't.
set, you don't. The radio
Radio's
picks it.
gonna pick it.
The radio's gonna pick it. It's part of the design. It does it. This is just information, so
So you
you,
get a,
see what it's doing.
radio.
uh, there are some.
Well, the reason you want to get it to a lower frequency, it's easier to amplify it and filter it at a
Right.
lower frequency than it is at a.
Because your higher frequency, the lower your signal is gonna be on a higher frequency, right?
Well, you've got a frequency coming in, okay, when you mix it, okay, you're gonna get a sum and difference. So the sum is gonna be a higher frequency than what you have coming in. The difference is a lower frequency than what you have coming in. So that's easier to deal with electronically,
Then,
which is why you normally down.
but the higher one's gonna be a narrower band,
No,
no?
no, it's just gonna be it's shifted to a higher frequency.
Okay.
If you think about it, in the digital realm, it's also true in the analog realm. But the higher the frequency, the more bits, because every cycle you can have a bit,
Okay.
okay? So that's faster clock times. And I would imagine that that due to the size of components back in the 20s and 30s, for the voltages to build up, the capacitance to build up, okay, that was limiting to going to higher frequencies. But now the components are so small, okay, that those times to fill a capacitor and drain a capacitor and fill an inductor and drain an inductor, all that gets down really, really small, yeah. So we can do high frequencies that we couldn't do 100 years ago.
Okay.
But it's still easier to do a lower one than it is a higher.
Yeah, yeah, and that's why you want to get it down low so you can do it easy instead of do it hard.
And in the case of an SDR, okay, if you did the high side, it requires a much more expensive analog to digital converter to be able to sample at those frequencies, which is very costly. If it even exists.
If it even exists. Huh. But we got some clever people working on that.
All right, so I'm gonna leave this slide to you, Bob.
To me, I always get confused on this one too, but we got Byron here, who's an expert on this.
Huh.
On the left is what we call down conversion. So if you look at the little diagram at the bottom, you see your RF frequency coming in from your antenna into the mixer with the local oscillator. What's actually happening, it's a nonlinear device and it's multiplying those two frequencies together. And it's like a vector cross product. So that you get, that's why you get the sum and the difference plus the RF and the local oscillator out. And that's what it's showing in the little chart above it, okay, where you see one labeled RF, that's what's coming in. The local oscillator is a little bit higher frequency. So the difference is your IF at a much lower frequency. That scale is DC to infinity frequency wise. So you're taking the RF signal and generating a much lower intermediate frequency. So it's a lot easier to filter basically. And that's how you get selectivity, is how good your filtering is on the IF frequency. over on the right-hand side, we're doing just the opposite, like you were doing an up conversion.
One thing, back on the first one again, since he mentioned that the IF is the difference between the RF and the local oscillator. Remember that there's also there's also a sum. So the sum would be higher than the local oscillator, but that's so far out of the picture that it doesn't fit on there. But we're not looking for that anyway. But when you come back over here, you've got the IF and the local oscillator, and that's why you end up with two results over here, because you've got the sum and the difference of those two. Okay.
Okay, old black magic.
Yeah, so your IF is your radio frequency.
Yeah, on the right, you're
Yeah.
bringing IF in to the
Right.
mixer and generating a higher RF,
For
RF1,
transmitting.
RF2.
Yeah, up conversions were going out, down conversions.
Those are your two side bands that you get with AM.
And there's more to the side bands if you decide to go on up to a higher level license after this. There's more to the two side bands that comes into play when you're looking at your spectrum scope. Knowing the shape of what the sideband is, you'll know where you need to position your receiver as far as frequency for receiving. Okay, so which of the following is used to convert a signal from one frequency to another?
Wouldn't that be a phase splitter?
Bravo.
Yeah. I was gonna go with Delta Airlines.
No.
Hear what I said.
Bravo, you said
Um,
Bravo. Now,
yeah.
is it just my eyes, or is Bravo look a little bit darker than the other ones on my screen?
We were admiring that phenomenon a couple of weeks ago.
So
Yes,
is it Bravo?
It is Bravo.
Oh.
Yeah.
On
I
your
want-
exam,
Is it my
you
eyes?
have that, yeah,
Yeah, like Byron said, come exam time, they'll all be in the same color.
It wasn't on purpose.
Yeah.
like
Okay,
that.
super heterodyne receivers use a local oscillator circuit to generate a radio frequency signal of a specific frequency. And that's what we have right here is a drawing of a local oscillator. And you're wanting to pick off a very specific frequency.
And if you were doing a general or extra exam, they'd want to know whether that was a Colpitts or a Hartley. You don't have to know that yet.
yeah, I don't either, because I've already passed that. Yeah, it's like the cold pits,
No, it's a Hartley.
that's a hard thing.
You had 50-50.
Yeah. It's all black magic.
I always remember Colpitts because it's C. It center taps the capacitors.
All right, C for center tapping the capacity.
Yeah. And this one has a center tap transformer.
Okay.
All right. Was there anything else we needed to?
No, that was just
Okay.
showing them what an oscillator looked like typically.
Yeah, the important part on this is that you remember that a local oscillator is used to produce a specific frequency for mixing. Okay.
Bravo.
I was just gonna say, don't strain too hard there. What is the name of the circuit that generates a specific signal at a specific frequency? And
Doggy, doggy, dog.
oh, you know what? This one here is actually
It's
actually-
throwing you off.
yeah. So
Bob did some cut paste.
the B there is distracting, but it's not the right answer.
Oh, okay.
Yeah, remember right there, local oscillator circuit generates a radio frequency signal of a
Okay.
specific frequency. So there, what is the name of the
It's
circuit?
delta.
Delta, an oscillator. And I don't know if they just left the local part off of that, but you know, an oscillator is an oscillator, an oscillator. It does the same thing all the time. Just how you use it determines what name it or
So,
title that it will
Are
have.
there any radio circuits that use remote oscillator like through the internet or anything?
I don't know of any.
Complicate thing.
Yeah, remote hams, you can remotely operate a transceiver. So you're tuning the VFO, which is an oscillator.
But
But-
the whole unit is remote at that point. So
So, but that wasn't what you asked.
So the oscillator is still local. It's just not local to where you're controlling it.
yeah, it's local to the radio. So do you have any oscillators that are not local to the radio?
Okay, so you got that, Robert?
I do.
Okay. All right. Now, see, mine didn't do this last night.
Oh, really?
Yeah, the automated, well, I mean, I wasn't watching the slideshow. I was looking at it on my iPad.
Oh, okay.
It didn't activate the. Okay, so AM and FM transmitters use a modulator circuit to combine a speech signal with an RF carrier to perform modulation. So the top signal that you see there, that is your audio signal. That's what's going in to your microphone and then being presented at some further point down the line,
Sometimes call that baseband.
baseband.
I can't do my voice that low because that's what, maybe
That's-
2 hertz or
That's pretty
something like
pretty
that.
low.
Subaudible.
Okay, so and then what you see there in red, you see the AM signal, and in blue, the FM signal. Now, AM, you generate a fixed frequency, fixed amplitude signal that gets mixed with your your audio signal. And then it superimposes by, well, I won't say superimposes. It varies the amplitude of the AM signal, and that's how you put the intelligence on the radio waveform. You'll notice that the top of the waveform is in phase and the lower part of the waveform is 180 degrees out of phase. If that signal gets too strong, Robert can't see me if I point to it. If the signal is too big, overdriven, it'll flatten out there in the middle where the
Red line.
red line, yeah,
I'll show you a trick
right click. Yeah,
and do mouse pointer, wherever it is. And you can draw.
okay. So if you, well, not while it's this part in the middle right there where
Oh,
it's yeah. So that part there will flatten out and that'll cause distortion. So if you overdrive your audio, that's what will happen.
It'll also tear up transistors. And will also tear up audio drivers.
Okay. So anyway, AM, the trainers that we worked on when I was in the Navy were AM trainers. So this was a lot of material that we went over. And these things were like 3 feet long, about maybe 1.5 feet square format. And they had like 12 cards in them. And the cards were all spread out because they didn't want us pulling the cards out and inspecting them, because then we would find the manufactured defects. They didn't want us to find the manufactured defects. They wanted us to troubleshoot it through signal tracing and taking voltages and stuff like that. So the cards were all spaced far apart so you could get probes into it and do actual troubleshooting rather than a visual inspection. And this thing was mounted on a gimbal so that you could turn it. You could roll it over and get to the bottom. You could roll it over to get to either side. And if they caught you eyeballing the board too long, they'd fail you.
Ah,
So you had to get in there, take your measurement, write it down, and move on. We weren't allowed to do a visual inspection. And nowadays, 90% of the things that I work on are fixed through visual inspection. So you go on down, you look at the blue waveform there, you'll notice that the frequency is being compressed and opened up, and that is in respect to the audio signal that's being applied to it. So if you're using FM, like on our handheld radios here, that's the way the signal would look. And of course, you know, some people's voices look better than others, but
What does over deviation look like? Does that become a sawtooth or what?
on the FM,
Yeah,
I don't know, but I do, it'll distort,
yeah.
but I don't know what the
the
signal
waveform
actually looks like.
Tell from the waveform, it has to do with the discriminator.
Okay.
Hmm. Yeah, and as far as turning up the transistor, that is a minor case. It's not the normal case.
Right.
Because
Okay.
you can use square wave rectifiers and things like that.
Okay. So anyway, this is your example of modulation. Any questions?
So I bet the next question has to do with a modulator.
Probably.
No.
Well, you didn't say the next slide. You said the next question. Amplitude modulation. You've got message going in, you've got carrier signal going in, and on the output, you have the variable amplitude signal. That's amplitude modulated. So you're using the amplitude to convey information. Okay, pay no attention to that. Which of the following describes combining speech with an RF carrier? You sure? Or you're just saying it because we just talked about modulation?
Cowbell,
Blade?
Okay,
oh,
let
okay.
me not,
Modulation.
yeah. Yeah, we were just talking about modulation there. So you combine the speech, the audio frequency of your speech with the RF carrier, and on the output, you end up with a modulated signal. Okay, so takeaways for this. Remember, the takeaways are important. This is what you really need to remember. A device, transceiver is a device that combines a receiver and a transmitter, so it's easier to go portable. A transverter is a device that converts. Remember, it converts. Transverters convert RF and RF input and output of a transceiver to another band.
thought gender doctors did that.
Yeah, we're not going to discuss that. Power amplifier increases the transmitted power output from a transmitter. Yeah, I'll tell you the story later. Power amplifier increases the transmitted power output from a transmitter. Single sideband, the single sideband CWFM switch, remember, sets the mode for your power amplifier. So it's going to be set up properly for the band that you're going to be operating. Don't forget about the difference between sensitivity and selectivity in your receivers. Remember, sensitivity is the ability of the receiver to detect a signal, although there's might be noise on the signal, but you want to be able to sensitive enough to pull the audio out of wherever the noise is. Selectivity is the ability to be able to decide which of two very closely neighboring signals you want to listen to. Your RF preamplifier should be installed between the antenna and the receiver. And as Bob pointed out, most of the modern units have it installed right in your radio, so you never have to worry about it after this test.
After the test.
Yeah.
Except when to turn one on or.
When to turn it on or off, yeah. And with some of them, they amplify everything, not just the signal you're looking for, but they amplify the noise too. The mixer is used to convert a signal from one frequency to another. By mixing, you remember on the output you have of the mixer, you're going to have the sum, the difference in the two original frequencies. Your oscillator generates a signal at a specific frequency. And it can be a local oscillator, and there are other types of oscillators too. Like I say, the job that they're where they're used will determine what if it's a local oscillator or a different oscillator. Modulation is combining your speech with your RF carrier signal. Any questions? No.
I'm so confused. Can we keep going?
Sure you
Don't forget to stop.
are. Okay, so there's one of the changes. Did you see what it did there? Instead of having a different line for
Oh, yeah, because